Hi. Today we are going to discuss the most important decisions you may take during your careers. We will discuss the things that whole world thinks about. We will discuss which framework to choose for our frontend. If you're like Anew, you choose Angular. If you are like Robert, you choose React. If you're like Vanessa, you choose Vue. And my name is Adam Bar, and I might have a different perspective. I'm the creator of What Web Can Do Today, the website that describes the capabilities of the web platform, especially in the context of mobile devices. Anyone already heard about it? Yeah, I can see a few hands, thank you. So on mobile, what do we care about is performance, because this is what the mobile users can actually perceive. And performance, one of the most important factors for performance is the file size, the bundle size, the size of the code we are shipping to our users. There's a great website called bundlephobia.com that summarizes what is the cost, what is the impact of adding a new NPM package to our application. So if you are like Vanessa and you use Vue, you are adding 23 kilobytes of minified code to your final bundle, and it takes almost half a second to download just a framework code on a emerging, so a bit of slow 3G connection. If you're like Robert, React DOM, the bigger of the two of React packages, takes 33 kilobytes and makes the download 66 milliseconds, 2/3 of a second longer. And if you're like Anew, just the core of Angular, just the package takes 75 kilobytes and is downloaded during 1.5 seconds. So in case I have a zoo and I have such a creature there, I wouldn't hesitate to call it Angular. Jokes aside, we have a website obesity crisis, definitely. Website obesity crisis is also a title of a great talk by Maciej Cegłowski that is have already it's few years old. But I really recommend you to watch it on YouTube. It's an eye-opener in terms of performance. It is very well done. According to the most relevant data we have from the httparchive.org, the median size of a single page view in 2019 is almost 2 megabytes. And it takes almost 70 requests just to show a piece of content on the screen. So majority of that is are media files like images and videos, but JavaScript is the second most important factor. And JavaScript matters twice, because it's not only a download time, but also parsing and execution time. And you might think, on my MacBook, it doesn't really matter because it's fast. Yes, your MacBook is fast, it's at the top of this chart. This chart is a chart how long does it take to execute a megabyte piece of JavaScript. But let's look in the middle of this chart. What do we have here? We have Galaxy S7, which is a flagship smartphone from like 2 or 3 years ago. We have older iPads. So those are not that bad devices from just a few years. Those are devices that our customers still have. And it takes 1.5 seconds just to execute that code, even after it is already downloaded. So I don't want to think about the low-end devices here. So I know what you're thinking now. This guy is trying to convince us to forget about all the frameworks. This guy is trying to convince us to go back to the era where all we had was a hammer or our bare hands and to manipulate the DOM structures by hand. I am not that radical. I use frameworks almost every day too. What I'm trying to convey is that we should always think about its cost. Before I offer you an alternative, let's look at the timeline of templating approaches we had in the frontend. Initially, all we had was a pure DOM API. So we had no abstractions. It was very crude and not pleasant to work with. So abstractions like jQuery were born. But it was still very narrow, a thin layer on top of the DOM API. We could optimize or work around it a bit with inner HTML. That was a trick to invoke the whole parsing flow and to put a string with HTML into the DOM structure. It was kind of fine. Although it was string, no one likes pure strings in the code. And performance-wise, it meant we were replacing potentially big chunks of the DOM structures, so it might hurt. Later on, we had templating libraries. We had something built into AngularJS. We had something in Ember. There were a multitude of standalone libraries like this. So it emerged as an abstraction layer on top of the native DOM API that abstracted all the details away. So it was more pleasant to work with, but we lost the possibility to run it directly in the browser. We needed to have the intermediate layer that translated that into a DOM calls. And performance-wise, it could be not that good too. The performance bit was fixed with the approach with virtual DOM we know from React nowadays, when we still have that abstractions on top of the DOM API. But thanks to that virtual DOM diffing, we are kind of safe from the performance problems when replacing whole structures in the DOM. But we still have that abstraction layer. We might find not the best possible solution. Do we have any solutions that have both the performance and are native to the web platform? And here is where the newest JavaScript standards came in. And there is something called template literals, known also as template strings. This is a new third type of string literal in JavaScript in ES6, also known as ES 2015. It doesn't use a single quote or double quote we are used to. It uses a backtick. This is a sign you have on your keyboard when your tilde is. And it differs in two ways. First of all, it allows us to embed any JavaScript expression after a dollar and bracket. And when I mean expression, I really mean expression. Like here in this example, we have a function call and we have a ternary operator. So it's not only a simple variables. We can put anything that resolves to a value into that bracket. And the second nice thing is that it can be multi-line without any problems. And you might think this is a future, this is not something I can use today. Actually, this is here and it's here to stay. 90% of the browsers of our customers support it natively without any polyfills and without any transpilation. So it is definitely available nowadays. The standard defines also a thing called tagged template literal, which is an extension to the tagged template literals, and it adds a word before the opening backtick. It looks ugly. I refused to accept it for a long time, that kind of syntax, but eventually I get used to it, and it opens a few possibilities. This my tag here is actually a function call. The function I defined below, and we can define it however we want. It's us who is responsible for to implement it. This function takes an array of parts, which is those parts that are static, that are never changing because they are like hard-coded parts of the strings, and it also gets values, and values are the values that are resolved from the dynamic expressions. So whatever we want to do with that, however we want to combine it, it's up to us. Whatever will be returned from the my tag function will be used as a result of this fancy template here. What are the use cases? For example, the documentation provides us with an example where we can additionally sanitize the input from the user. So to avoid XSS vulnerabilities, for example, we can apply a sanitization just to the parts that are dynamic, that are coming from the user, and not to the parts that are hard-coded and controlled by us. But that was something that we could do before tagged template literals, obviously. But it opens up more possibilities. So here comes LitHTML. Lit is a name that came from little lightweight literals. What it is? It's a tag, actually. It's a tag to be used with template literals. It's called HTML. And it also provides a render function. The render function that is supposed to accept a template, something that was tagged with HTML, and a DOM element. So you might think of render as a function that uses the element and puts the template into its inner HTML. That would work. This is conceptually how it works, but it would make us move back in the performance-wise to 2010 or before. This is actually a bit more efficient. A bit. This is using JavaScript, HTML templates thing that is stored into the DOM, and it is using the tagged template literal to analyze the structure of the template. So if we call the render once again with the same template, it knows exactly where in the DOM tree the change should be applied, and it is able to compare the values so that the most efficient way it is applied in the most efficient way. So in this example, you can see even though the whole template is re-rendered every second, it's only the number that is updated. It's also efficient because it takes 66 milliseconds to download on the slow 3G. So a lot less than the frameworks. It is not obviously not a framework, but just to render a content, it's all we need. It's also not that simple. We can do more using that. We can create a structures. We can embed templates into an outer templates. We can parameterize them with some arguments from outside, so we can build some kind of DSL on top of that. Okay, let's try it out. I have an application that all it does at the moment, it displays hello world, and we will start adding something here. Can you see the code? Maybe I can make it a bit bigger. Okay, we'll start with a placeholder. We call it my app, and we'll render our application here. We'll need to add a JavaScript here. How to add a JavaScript in 2019 if we're brave, if we are those people that attend the conferences, so we are on the bleeding edge? Obviously, using modules, because this is what works in all the modern browsers, and I mean all, including Edge and Safari. And I can use the same concept of imports and exports that we know if we're using Webpack or anything. Here, I will just import it as a module. I will import the code as a module, even though I have nothing in between the code and the browser. So I'm running this in my Chrome directly without any transpilation, without any Webpack underneath. Okay, let's create a file called app.js. It will be our module. And what we will do here, we will define a template. This template will be using that HTML tag, and we will render something like hello from library, where the library will be defined dynamically, or at least it will look like defined dynamically, lit HTML. And we will render that into this, we'll render this template into document, get element by ID, my app. Okay, HTML and render would need to be imported, so we'll just use import like we'll do it in the Webpack driven code, even though we don't have any Webpack here. So I have those files on my disk so that I'm not relying on the internet connection. You might obviously do the same, or you might download it from any CDN in the internet or anything. So let's check it out. Here it is. It was rendered using lit HTML. That was not anything impressive, I know. So let's write an application that, for example, calculates how many days left to our vacation. So days left to holidays. And days will be calculated as a comparison to the target date, which we'll set, for example, to the 1st of June. And the calculation would go, days will be the difference between the target date and today. So we have the difference in milliseconds, so we need to divide that into by 1000, so we have seconds, by 60 to have minutes, by 60 to have hours, and 24 to have days. And we will round it not to have any decimal numbers. Okay, and have a look. So 17 days left to holidays. Great. So far we only used lit HTML to render a text, but it's not limited to that. Let's wrap the days with a span and add a conditional formatting here. How to do a conditional formatting? Let's have a class, and instead of those quotes, we'll put an expression here. And expression would be a ternary operator. If the number of days is less than 30, let's use a class soon, otherwise use an empty class. And here, now it's blinking because it's less than 30 days. Fine, so we were able to render something into the class node. Okay, this application is still very simple. It's not configurable. Not all of you starts your holiday in 17 days probably. So let's make it configurable so that it works for you. My holidays start at, and let's have an input here. Input type date. So it will look like this. Okay, the initial value we might bind again using this same syntax from the target date. So it will be filled with the value. When we're changing it, nothing happens. We need to bind, we need to listen for that event. How to do it in LitHTML? There's a syntax with @ sign. The name of the event goes here, and then there's an expression again. This is a very lightweight syntax that all it does, it calls add event listener on the rendered element using this as a event we are listening for, and the thing on this on the right is directly put as a listener for that event on target date changed. So let's define that function. It will take an event. It's a native DOM event. And what should we do here? We need to re-render everything once again. How to do it best? Let's wrap this whole code in a function called re-render. Let's fix the formatting. And this re-render function will take target date as a parameter. And the first time we will call it here using this value as an initial value. We don't no longer need here. And here we just need to call re-render once again. Event target value, which is the value taken from the input. Let's check it. Okay, it changes when I change the value here dynamically. So let's check, am I lying about that updates. So the only thing that actually is changed is the number, and the class is added or removed depending what's the value. Even though I am re-rendering the whole application using this function. Okay, it's still a bit simple. We are developers, so we plan to conquer the world for sure. So let's make this app universal, and let's make it a universal counter for everything. So not only holidays will be parameterized. Let's add an input here. Input type text this time, and let's make this text holidays also a parameter here, expecting for. So we will use this value expecting for instead of this text. We will use it as an initial value of this input here, and we will pass holidays as a value for the first render. Okay, so it looks like this. Okay, nothing happens when I change it because I haven't yet bound it, and moreover, when I change the value here, it gets removed because I am not passing anything here. So obviously I need to add my handler key up this time so that we can see the changes immediately on expecting for changed. Changed, is it? Yes, it is. So again, function that takes an event that needs to re-render. Okay, but we don't have a target date here. We don't know it. We might look into a DOM like we did in jQuery era, but this is something we don't want to do. We will handle it the same way frameworks do it nowadays. So we'll introduce a concept of state. State will be an object that keeps these values. So here will be used as a parameter, and it will have target date as a property, and it will have expecting for as a property. And this will be passed here as a parameter. Here we can use the structuring not to change anything later. And here we can also pass the state in, and all we need to do is to modify that state before calling re-render. So here target date will be modified, event target value, and the same here. So we will change it to state expecting for. Okay, here it is. It should work now. I can change the name, I can change the value. Great. So we have 40 lines of code. We have an application that is right now able to conquer the world. And it was very simplistic with almost no dependencies. What I don't like here is that I need to call that re-render manually, and I need to track this state manually. It kind of bothered me. It's fine for the application of this size, but it doesn't scale, obviously. We could build a framework on top of that, obviously, but the idea of this talk today is to use what platform offers, is to avoid large frameworks. So let's think: is there something on the web platform that allows us to fix our problem in a platform-specific way? Web components. Anyone already heard about it? Anyone is using that seriously? Someone on production? 2 hands. Great. What web components are? Is this basically the same idea that we have in all the frameworks nowadays? It's a piece of reusable UI and functionality closed in a encapsulated manner. It's the only way it is actually possible to have the total isolation, because what frameworks do, they try to pretend an isolation. With web components, because they are native to the web platform, this is the only way to actually have that isolation deeply supported by the browser. The most visible way we can see it is with CSS. With frameworks, we can try to avoid CSS collision with things like CSS modules or scope CSS. Here, with web components, the components are rendered into a shadow DOM, which can be thought of a separate DOM structure within the outer DOM structure, and the CSS from the outside does not apply to the inside by default. So this is the only real separation thanks to the fact that web components are implemented directly in the browser. Why that only 2 hands were up when I asked who uses that on production? Because for years web components was something from the far future. It changes very recently. Right now it is supported natively in all the browsers except Edge, and Edge is moving to Chromium, so it will get web components really soon, like off the shelf. So what we can do almost today, we can go back to the era where the code we were writing in the development is the same code we are running on production. Most of us doesn't even remember those times when we had no transpilation, we had no bubble, we had no polyfills, we had no bundling. Right now with HTTP2, with ES 2015 in the browsers, and with modules, we can go back to this era. When including JavaScript using modules, we can forget about bundling, we can forget about transpilation, we can forget about polyfills, and serve to the 90% of our users the code exactly like we are writing it in production. For the poor 10%, we can still go through the classic route with transpilation, polyfills, and so on. So, but the majority will get the code that is lightweight and modern. This is something that really clicks for me. The only problem is Edge at the moment, because it supports modules, so it loads the newer bundle, but it doesn't support web components yet. But again, I wouldn't call it a big problem if you are starting a greenfield project today. Before you're ready for production, Edge will support it because they will adopt Chrome. The beta version is already there, which actually supports it, so that is not a large issue, I would call it. Okay, why I'm talking about that and how it relates to LitHTML. LitHTML was made by Polymer. It's a byproduct of Polymer, and Polymer is a framework from Google that was an incubator, let's call it, for web components for years. So people that invented LitHTML were aware of the problem we found with the double render, with the manual render, and they found that web components is actually a way to solve it. And this is how LitElement was born. LitElement is a something that connects LitHTML and web components. With LitElement, we are actually writing a web component, a custom element. So we are binding into a DOM parser. We are defining our custom element that we can put into HTML, And we have a base class called LitElement that implements all the web component stuff underneath for us. And all we have to do is to define a render function. If you're writing in React, you might it might ring a bell a bit. All we have to do is to define a render function that is supposed to return a template, lit HTML template. This template has its all advantages of lit HTML. So we can embed any JavaScript expression within this template, and it is rendered with that optimization that only the most specific changes are applied. It's a class. It's always a class. We can have a constructor in the class. If there's a constructor, we can take the values from the outside. So we can parameterize that and have those values written into class fields. If we also define a static getter called properties and list the class fields that we use by the name and their type, we are asking LitElement to observe on those values. So whenever those values changes, LitElement is responsible for calling our render function again, just by calling it. And LitHTML already handles the optimal way to update our DOM. Last part that we need to remember is that glue at the bottom. We need to register our class as a custom element into the DOM parser directly. So whenever in HTML the browser encounters my element, it knows that it is handled by our class, and it has the parameters that should be passed as the parameters of the constructor. Let's try it. Let's change this code into a LitElement code. So we need to define a class. Let's call it my app, and let's extend LitElement. I will import LitElement from my disk. Oh, here it is. And we need to define the render function. That is supposed to return a LitElement template. We have this template here. Let's reuse it. Okay, we need to define those. We need to have those days calculations because it's still useful. We'll put it into a render function, and we no longer need this piece of code. It's useless. Okay, we will use class fields. So I will append this before all those underlined stuff. This expecting for, this expecting for, this target date, and let's define it in a constructor. Constructor are super. Here target date. We'll take the target date from the constructor parameter. We can fall back to a default value. Let's have last day of the year. And the second one is expecting for, and again we'll read it from the constructor parameter and fall back to holidays. Okay, now we can use it. Here instead of this div, we can put my app and pass the value target date that we had before, so it was 1st of June. Great. Does it work? Not at all, because we forget about few things. First of all, our class is not used. It's even highlighted as not used because we haven't registered it in as a custom element in the browser. Custom elements define whenever you encounter my app as a HTML tag, use this constructor, it will handle it for you. There's a convention that all the custom elements for web components need to have a dash in the name because there's a promise in the HTML standard that the built-in elements will never have dash in. Okay, is it better? Yeah, something was rendered. You might see or you might not see that it loses its formatting. The CSS was not important, so we have a proof that we have a real web component rendered here. We have a shadow DOM here as a separate node in the DOM structure, and CSS from the outside was not applied to the inside. So that's great. That is great from one side. That is a obstacle from the second side. We will handle it in the worst possible way. This is definitely not the way you should handle that on production. I will copy the CSS from the outside into inside. It's just to have something simple for the demo, and wrap it into the same div here. There might be a separate talk, probably a whole talk about how to handle CSS within web components. I'm not going to do that. Paste from history, please. Here it is. Okay, it's styled now, but the value is not applied yet. The value of our 1st of June date. It is not applied because we haven't defined that strange static get properties thing that allows LitElement to observe our fields. So let's define it. It's an object that has target date and type of string, and it's expecting for type string. Here it is. Okay, now it gets applied from the HTML. Note that the only place that defines the date is the HTML code. When we change, we have errors, obviously, because we haven't done anything with the event handlers. What we'll do is we'll do the same what frameworks do. We'll put that here as a class methods. So let's remove that const. Let's remove re-render because re-render is no longer there. Let's replace this with this because now the values are kept in the class fields. And here we'll need to also add this because we've moved those functions to the inside. Okay, we no longer need state. We no longer need that import. It should work now. Okay, and we are back to the situation where when it works. All we have right now is a class and its registration into a parser. It takes 50 lines of code to have something that does not require any manual re-rendering. It's handling the updates for us. It's taking the values from the HTML outside, and it's rendered using the most modern web techniques with web components. So we are on the bleeding edge as we like it. If we have TypeScript in our dev environment, we can make it even simpler with the support of experimental syntax with decorators. So we can enable it and remove that strange static getter with add property for the fields we want to observe on. And we can remove that glue line that binds our component into a DOM parser with the annotation above with custom element myElement. So it makes that code even cleaner. But it's still a web component, so we can make use of everything that web components offer us. So we can override the functions, the lifecycle functions that are provided by the underlying web components infrastructure. So we can define connected callback, should update, updated, and so on. Again, if you're a React developer, you might see how it compares to the lifecycle methods in React, like component did mount, component did update, and so on. This is almost one-to-one mapping to those ideas. When comparing to React, it gets pretty much apparent to me that the ideas are the same in both cases. On the left, we have the LitElement component. On the right, we have the same equivalent component written in React. It's even visually very, very similar. The concept is like almost the same. The difference, what's the difference? The difference is that LitElement, together with LitHTML as its dependency, is 6,6 kilobytes, and it takes 130 milliseconds to download on 3G. Again, this is obviously less than React offers, but the simplest use case, just to render a dynamic content and update it dynamically, can be solved with such easy tools without much overhead. What's my conclusion then? First of all, I'm pretty much worried when I look at the job posting boards for front-end development that half of these postings are looking for React developers or Angular developers. So it's like we are looking for a painter to order a paint for our bedroom, and we ask them what kind of brushes do they have, not if they can't even paint. So Angular and React are just the tools. Are tools that will no longer be with us in a few years' time, probably. That's possible. And we shouldn't be framework-only developers that focus on a single tool that is our hammer and everything is a nail for us. We should be trying to solve our customers' problems, and there is always many options. How can we solve it? There are plenty of solutions that apply to different types of problems. Not every single application requires a whole framework to be pulled in. Not every application is the same, and not every application makes sense to use Angular, for example. Obviously, there are applications where Angular makes total sense, but there are applications like simple landing pages with few dynamic elements, or mockups, or applications that calculate how many days left to our vacations, that we might implement using that very simplistic techniques, even though they are immature, and have the job done. And the third thing is that size matters. No matter what they say you, I believe size matters still, especially on mobile. The less code we ship to our users, the less is the waiting time of our users. Also, the less money our users need to pay for their data plans in some cases. And there is a research, or actually a lot of research, that shows what is the relationships between the bundle size and the waiting time, how long the user needs to wait for the page to load, into a business-related metrics like conversions. And conversions translates to revenue for our business, kind of directly. So size matters. Thank you. That's all I have for today. I'm open for questions. I will be here. I will be here in the corner also. And you can also ask questions via that Slido application.